On this worksheet, we're going to be solving precipitation reaction problems. The first 6 problems on this worksheet, they all pertain to the exact same precipitation reaction. It's basically like the 6 steps that you would take when you're solving these types of problems. So step 1 is going to be to take the reactants. These are the 2 reactants for this problem. Take these 2 reactants and separate them into ions. If you're not good with like looking at a molecular formula and knowing what's the cation, what's the anion, it's going to be handy to consult a table of solubility rules because we're going to need that anyways to solve these problems. In tables of solubility rules, they all look super different from each other. This is the table of solubility rules from Alex, and it has all the cations on one side and then the anions across the top. And this one is actually, pretty handy because this is what it looks like on Alex. So here is the lead cation. We can see it down here on the table of solubility rules. It's going to be important that we include the charges on these ions. I'm not going to include the states. I'm not going to write AQ because that's not like super necessary at this point. And then in this PbNO3, the other ion that we have is the nitrate NO3 ion. That's a polyatomic ion. And we can find that nitrate ion on this table right over here, NO3 minus. So we'll add that as well. I'm going to put the 2 in there because there are 2 of these nitrate ions. That's what this little 2 right here means. And then for our other compound, we have sodium ions. That's going to be Na plus, and iodide ions, that's going to be I minus. And I'm using the 2 here because this 2 is telling us that we have 2 Nas and we have 2 Is. So get everything separated into the cations and anions. The next thing that we're going to do is predict the new products for this reaction. So to do that, we're going to take a cation and combine it with a new anion. Let's just start with the lead 2+, Pp2+. We're going to combine this because it's a cation. We want to combine it with an anion, not with the nitrate because that's what we started with. And we don't want to combine it with the other cation because that doesn't make sense. Positive charges repel each other. They don't attract each other. So that means we want to combine the lead with the iodide. We want to put this together. It's been a long time since we've practiced this, but put this together in a way that we make a neutral compound. Looking at the charge of the lead, Pb2+, that means we need 2 iodides to neutralize that 2+ charge. So one of our products is going to be Pbi2. And then our other product is going to come from the sodium and the nitrate. We traditionally always write the cation first, Na, and then our anion, NO3. We don't really do much with the 2 here. Like I guess you could put the 2 in front if you wanted. But these are going to come together in a 1-to-1 ratio because we have the +1 charge and the -1 charge neutralizing each other. So we need just 1 of each of these. Once we get these formulas put together, we're going to be using the solubility rules. That's what's over here to predict whether the product will be solid or which product will be solid and which will be aqueous. So of these 2, one of them is going to be aqueous for sure. That means it dissolves in water. And then the other product is either going to be also going to be aqueous, or maybe it's going to be solid. The solubility rules are going to tell us what's what. So to read the solubility rules, what we need to do is find the cation. So that is looking on this column, we find our cation, and then we need to find the corresponding anion, which is I minus. So we need to look for the box that corresponds to Pbi2, that's this box, and on this table, no means it's not soluble, which means it is a solid. So our Pbi2 is the solid, and since we've already figured out which one is the solid, that automatically tells us that the other guy is going to be aqueous. So we know for sure that, I'm going to make a note on this, one of the 2 compounds is definitely going to be aqueous, and the other compound is either going to be aqueous or solid, one or the other. So if we right away find the thing that's solid, then we know the other compound is aqueous. Write a balanced molecular equation for the reaction. A balanced molecular equation is looking like this. So we're going to write the complete formula for each one of the reactants. That's way up in problem 1. PbNO3 2 aqueous plus 2 NaI aqueous. And then we're going to write the complete formula for both of the products that we predicted. PbI2 solid, and NaNO3 aqueous. And it is crucial that we include the states, solids and aqueuses. We can't leave them off. I would love to leave them off, but we can't leave them off. Next thing that we're going to do is write an ionic equation. So in the ionic equation, we're going to take everything that is aqueous and we are going to separate those things into the cations and the anions instead of writing them as molecules. So that means instead of PbNO3, we're going to write Pb2 plus and 2NO3 minus, and we do need to include the states. And then our other reactant, 2Na plus and 2I minus. Our first product, PbI2, that's a solid. We don't separate the solids. We only separate things that are aqueous. And then our second product, actually, I don't think I balanced this equation. There needs to be a 2 in front of the NaNO3. 2Na plus aqueous and 2NO3 minus aqueous. These precipitation problems are like my least favorite thing in the world because they are so tedious. Last thing we do here is write a net ionic equation. So for the net ionic equation, we're going to base it off of the ionic equation. And what we're going to do is find everything that exists in the exact same form on the left side and the right side. It has to be exactly the same, no slight changes at all. So Pb2 plus is not exactly the same as Pb when it's part of a solid. So what I've done is highlighted the things that are exactly the same. We're going to omit them to write the net ionic equation. So that's just going to be Pb2 plus aqueous plus 2I minus aqueous makes PbI2 solid. Like I said, these problems, they are so tedious and so unpleasant. It doesn't even, I don't even want to write them neatly. Okay, so we're going to do this 2 more times, right? The balanced molecular equation, the ionic equation, and the net ionic equation for the following reaction. So the first thing that we want to do is separate these into cations and anions. We have our Ag plus and our NO3 minus. That's our first compound. And our second compound is K plus and Br minus. And actually, if I am being smart, I'm just gonna put the states right on these little guys. So I'm just kind of gonna try to make it set myself up for the total ionic equation for these problems, like that. So there's all my reactants separated into cations and anions. Now what I want to do is take this first cation and I want to combine it with something new and exciting. I can't put it back with NO3 minus because that's what I started with. I can't combine it with K plus because they're both positively charged and they repel each other. So that means I need to put it with the put it with the Br. That's going to give me AgBr. They're going to combine in a 1-to-1 ratio because they both have a charge of 1, +1, and a -1. And I'm putting it up here in this first equation as a molecule. Let's leave a little space for us to write in whether it's a solid or an AQ, and let's write our other product. So our other product is going to come from the K and the NO3. Remember that we want to write the cation first. That's just our convention, and then the anion comes second. And this is also a 1-to-1 ratio because we have a +1 charge and a -1 charge. And we're going to need to look up what these are. So of these two, one of them is going to be aqueous for sure, and the other one is either going to be solid or aqueous. So looking at this table, what we want to do, well, let's look for AgBr first. We want to find our cation. It's all the way down here in the bottom row, and now we're going to go across until we find the anion, which is bromine. That's this guy right here. And on this table, no means no, it does not dissolve, which means that it is a solid. So boom, we have found our solid. Only one of them is a solid. The other one is aqueous. Autopiloted a double parentheses there. So this what we have right here is the molecular equation. That's the molecular equation. Now down here, I'm getting set up to write the ionic equation. The ionic equation, everything that's aqueous gets separated into cations and anions. Things that are solid, we don't separate. So AgBr will leave together as a solid. And then KNO3, because it's aqueous, that's going to get separated into cation K plus and anion NO3 minus. And then last but not least, the net ionic equation. So in the net ionic equation, we're going to cancel off anything that appears on both the left and right side of the equation in the exact same form. I'm going to see if I can copy and paste. So I've copied my ionic equation, or my total ionic equation, and what I'm doing next, I'm going to do it down here because I have a little bit more room down here. I'm going to look for things that are identical on both sides of the equation. Ag plus is not identical to Ag as part of a solid. That's not identical. I have NO3 minus. That's identical, so I don't want that in this equation. I'm going to erase it. K plus, identical in both equations, so I'm going to erase that one as well. K plus and K plus, and then what I have left is the ionic equation, the net ionic equation. I'll put that back up there. Okay, we get to practice this one more time. Let's do the same kind of strategy. So what we're going to do is take these and separate them into their cations and anions. We have Ca2 plus, that's aqueous. We have 2 chlorines, so we need 2 Cl minus aqueous. We have, and if you're wondering like, whoa, how did I know that there were 2 of those and that it wasn't a Cl2 sort of a deal? Remember, you can always refer over here to this table of ions, and you can see that Cl minus is a thing, but you're not going to find Cl2 anywhere on this sheet, which is telling you that Cl2 is not a thing. It's not an ion. And then we have 2 Na pluses. And if you're wondering where did that 2 come from, that's the stoichiometric coefficient. So that means we have the 2 here means we have 2 of the cations and we have 2 of the anions. The anion is hydroxide, OH minus. And next thing we want to do is take this cation, calcium, and combine it, not put it back together with the chlorine. Don't try to put it together with the other cation. Instead, we want to combine it with the hydroxide. We have a 2 plus calcium and a 1 minus hydroxide. That means that we need 2 of those hydroxides to neutralize every one of the calciums. And we're going to have to go look this up to see if it's a solid or if it's aqueous or what. Our other product is the Na and the Cl. There's going to be 2 of those because we have 2 Nas and we have 2 Cls, and we're going to look that one up as well. And remember that we always write the cation first, the anion second. So it's NaCl, not ClNa. Okay, now let's go look these guys up on our table of solubility rules. We want to start with calcium hydroxide. First, we want to look for our cation. It's right there. Now we want to go across the anions and find the hydroxide. And I'm actually going to use the highlighter so I can keep track. So here's my calcium. Here's my calcium. Here we go. Here is what we're looking for is right here. Our hydroxide is there. So this is the box that corresponds to CaOH2. No, meaning that it is a solid. And remember that only one of these is going to be a solid. So as soon as we have found the solid, we know that the other thing is aqueous. This is the molecular equation. Let's continue the ionic equation. In the ionic equation, everything that's AQ is separated into cations and anions. Things that are solid are left intact. We don't separate those. CaOH solid plus 2 Na plus aqueous and 2 Cl minus aqueous. Oh my gosh, so tedious. Last thing we want to do is write the net ionic equation. So in the net ionic equation, we only include the cation and the anion that are contributing to the solid product. That's not the same way that I've phrased it. That's different from how I phrased it in the previous problems that we did. In the net ionic equation, we eliminate the ions that are not changing, or we eliminate everything that's identical on both sides of the equation, which in this case is the chlorine and the sodium. Another way that we can think about putting the net ionic equation together, we're going to write our only product is going to be the solid, and so we just want to write the cation of the solid and the anion of the solid in the net ionic equation.